Hey folks, this one is going to be constructing a confidence interval. Let's see, so video screen tension. So a manufacturer of high resolution video terminals must control the tension on the mesh of fine wires that lies behind the surface of the viewing screen. Too much tension will tear the mesh and too little will allow wrinkles. The tension is measured by an electronic device with output readings in millivolts, MVs. Some variation is inherent in the production process. Careful study has shown that when the process is operated properly, the standard deviation of the tension readings is 43 millivolts. Here are the tension readings from an SRS of 20 screens from a single day's production. Okay, so here they are right there. Okay, so what we're going to do is we're going to construct a 90. They're asking us to construct a 90% confidence interval for the mean tension mu of all the screens produced that day. Okay, so let's go through the inference procedure. So step one, identify the population of interest and the parameter you want to draw a conclusion about. Okay, we are, the population is all video terminals produced on the day in question, and we want to estimate the mean tension for all these screens. Okay, so step two, choose the appropriate inference procedure and verify the conditions for using the selected procedure. Okay, since we know the standard deviation, we're going to use a confidence interval for the population mean. Okay, so I just taught this in my class. This is a lesson I pulled out, and we're going to estimate the population mean. We're going to use that sample. So now we must check that the two requirements of the conditions are met here. So the data comes from an SRS, so that's important, of 20 screens from a population of screens produced. Okay, now are the samples normal? Well, it didn't say anywhere normal, so past experiences say yes, and since this is under 30, you guys, the central limit theorem does not ensure that it's going to be normal. So we're going to examine the data. We're going to make a stem plot. You can make a stem plot or whatever kind of graph, a histogram. Stem plots are usually the easiest, you guys. Now this stem plot, for example, this 3/2 right here, this means 320 right there, so to 329 right there. So here's all the 20 screens right here, okay? So this 23 is 230 to 239. Okay, so that's all the screens on that one right there. So there they are right there, and look, that's that's pretty reasonably bell-shaped. There's no clear outliers on that, so or strong skewness on that. So the conditions are met and carry out the inference procedure. So now we're going to use our confidence interval. So our confidence interval is the mean plus or minus your z-score for your 90%. Standard deviation, I think they said was 43 divided by the square root of n, which is 20 right there. Okay, so we're going to go ahead and plug all those numbers into our calculator, and we get a mean of 306.3. So that's what goes right here. All right, and then for a 90% confidence interval, our z-score is 1.645, and then we plug it all in and we get a confidence interval from 290.5 to 322.1. This is my 90% confidence interval, okay? Or they would write it like that right there. All right, so interpret your results. So we're going to be 90% confident that the true mean of tension in the entire batch of video terminals produced that day is somewhere between 290.5 and 322.1 millivolts. Okay, take care, you guys.